Hi everyone. Today we'll be discussing the LeetCode problem of today, successful pairs of spells and potions. Here you are given two positive integer array spell and potions of length n and m respectively. Spells of I represent the strength of the ith spell and potions of j represent the strength of the jth potion. You're also given an integer success. So here a spell and potion pair is considered successful if the product of their strength is at least success. So you have to return an array pairs of length n, where pairs of I is the number of potions that will form a successful pair with the ith spell. So that means if you have a spell array as follows of length 3, so you have to return an answer array, a pairs array of the same length, where pairs of I will denote with this 5 how many pairs of potions will be successful. That means if you multiply 5 with the potion, the value should be at least success. So if you see for this input, 5 can be paired with, let me also write the potions 1, 2, 3, 4, 5. So for this 5, it can be paired with potion 5 or potion 4 and also potion 3, because 5 into 5 25, 5 into 4 20, 5 into 3 15, and also I think 2, because 5 into 2 is 10. So all these product values is greater than equal to 7. If we take 1, 5 into 1 is 5, which is less than 7, so you can't, 5 and 1 won't form a successful pair. So for the 5, you have answer as 4. Now if you see for 1, even if you take the maximum potion here, you won't form the value 7. So answer for this will be 0. Now for this 3, if you take 5, the product will be 15. And if you take 4, the product is 12. And if you take 3, the product is 9. And if you try to take 2, the product is 6, so it is less than 7, so you can't take this 2. Also, if you take the 1, the product is less than 7, so you can't take 1 as well. So answer for this will be 3. Now let's quickly look at the second example. We have 3, 1, 2, and the potions are 8, 5, 8. So this is the pairs array, and the success value is 16. So for 3, we can choose this 8. 3 times 8 is 24, but we can't choose this 15, because 3 times 5 is only 15. 15 is less than 16. For this 3, we can also pick this 8. So total 2 pairs. For this 1, no matter what you pick, the product is always less than 16. So no pairs. And for the 2, you can again pick 8 and 8, because 8 times 2 is 16. If you pick 5, it will be 10. So for this also you can have 2 pairs. So the answer is 2, 0 and 2. Now let's go over the approach. So suppose we have the spells array as follows: 5, 1, 8 and 3, and the potions array is 1, 2, 3, 4, 5. Now for each of this element, we need to find the number of pairs with the potions that will be successful. So if you want to get the answer for 5, all you have to do is iterate on the potions array and just check if my spells of I into potions of j, if it's greater than equal to this success value, then just take a counter and just increase it, counter plus plus. So you'll do this for all the elements, and how many elements product is greater than equal to success, it will count them, and at the end it will add in the array. And so for the 5, 2, 3 and 4 and 5, these numbers will contribute to this count. Similarly, if we check for 1, even if we like when we iterate on all the elements, no elements product with 1 will be greater than 7, so this is 0. And for the 8, all the elements product will be greater than 7, so this is 5. And for the 3, we have these 3 elements product with 3, which is greater than 8, so we have 3. So for each element, if we want to get the count, we are iterating on all the elements of the product array and getting the pairs. So the total complexity will be n into m. And if we quickly check the constraints, n and m are up to 10 power 5, so n into m will be 10 power 10, which will be too slow, so we have to optimize the code. So let's see. Now suppose we want to find the answer for this 5. Okay, not this. Let me just take a new example. If I have my portions array as follows: 2, 4, 5, 7, 8, 10, 12. And let me also write the index 0, 1, 2, 3, 4, 5, 6. So suppose this is my portions array, and in my spells I have a spell 3. So if I want to find okay, and also the success value is 15. So if I want to find the number of pairs from the portions array which will give me a product greater than 15, so I can see all these numbers will give me the product greater than 15. So in this, what is the least number? So least number is 15, 5. 3 into 5 is 15. So if I know that if I am able to form the product 3 into 5, which is at least greater than 15, and if the array is sorted, so all the elements to the right side of this particular element will be successful, because with 5 only I'm getting a product which is greater than or equal to 15. So if I try to increase the elements, then obviously the product will be greater than 15. So by this we can think of a binary search approach. So what we do is we sort the product portions array first, and from the portions array we have the spells 3. So in this array we will perform a binary search to find the first index that is successful. So the first index is index 2, because 5 into 3 is 15. If you check for the 4, if you check for index 1, 4 into 3 is 12, so it is not successful. So when we perform a binary search, we can get the index 2 as the first index that is successful. So binary search runs in logM time. So once we have index 2, all we need to do is we need to count how many elements are towards the right of this 2, including 2. So that we can do it by getting the size of the portions array minus the index 2. So here the size is 7. So 7 minus 2, which is 5. So that means total 1, 2, 3, 4, 5. Total 5 elements are greater than equal to, the total 5 elements product with 3 will be greater than equal to 15. So answer will be 5 for this case. So the same approach, let me just quickly dry run for the first input, and then we can go with the code. Let me bring this back. Yeah, so our first step is we need to sort the portions array, and sorting will take n logN time. So after sorting, what is this? Yeah. So after sorting, first let's see for 5. So for the 5, like initially we will set the index as n. It will be out of the array. First, let's say no elements are contributing to the product, and here the success value is 7. So in the binary search, when we get the mid, what we'll check is if spells of I into portions of mid, if it's less than what do you say, success. Yeah. So if I am taking a mid 0 1 2 3 4 1 2 3 4, so currently my mid is here. So with this mid, if my spells of I into portions of m is less than success, that means no matter if we move to the left, we won't find a value which is greater than success. So in this case, we have to move to the right. So we'll just say L equal to mid plus 1. And in the else case in the sense spells of I into portions of m is greater than or equal to success. In that case, we have found the index. So we will update index equal to mid. And after that, we want to find a better index. So we want to find a lowest index so that our pairs will increase. So we'll just set r equal to mid minus 1. So in this example, the mid is 2. So 3 into 5 is 15. 15 is greater than 7. So initially, index will be here. We'll store index here and we'll set r equal to mid minus 1. So L will be here, R will be here. Now again, if we try to find the mid, so the mid will be at this point. So now if you see 1 into 5 is less than success. So you move L equal to mid plus 1. So L moves here. Now mid will be here. So now if you check the condition again, 2 into 5, 10. 10 is greater than or equal to success. So it will go to the else case. It will update the index from here to here. And then it will also update the r equal to mid minus 1. Now since r goes here, L less than or equal to r condition fails. So your loop breaks. So when your loop breaks, you see that your index was at this point. So that means this is the least number with which you can form a successful portion. So the number of portions will be n minus index. So n is 5, 5 minus 1, which is 4. So for this, you can get the answer as 4. So similarly, if we check for the next index. So for the 1, if we try to do the binary search, first we will fall at 3. 3 into 5, 3 into 1 is less than 7. So we keep moving L forward. So again, we'll check at 4. 4 into 1, it's less than 7. So we'll again move forward. So we'll again check for the 5. 5 into 1 is still less than 7. Again, we'll move the L forward and the loop breaks. So like we discussed initially, we will set the index equal to the size of the array. That means out of the array. The indexes are 0 to 4. So we'll set index value as 5. So in this case, answer will be n minus index. So that means it will be n minus n, which is 0. That means for this 1, we don't find any pairs. So answer will be 0. Now if we check for 8, for 8 we can see our index will end up here when we do the binary search. So the answer will be 5 minus 0, which is 5. And for the 3, our index will end up at here. So answer is 5 minus 2, which is 3. So this is how we do the binary search to get the answer for each spell in login time. Now let's quickly code the approach. So let me just get the spells.length and create a new answer array, pairs, and size will be n. And after this, we need to sort the portions array, arrays.sort portions, and then just iterate on the spells array, I++. Pairs of I will be, so for this we can just use a function which will calculate us the number of pairs. It will be successful. So I can say find pairs. So the spell value will be spells of I, and I'll also pass the portions array and this success value, and at the end just return pairs. Now let's quickly fill up this find pairs function. The return type is int because it is returning the number of pairs. In spell portions and long success. So now again let's get the size of the portions array. L will be 0, R will be n minus 1, and initially I'm setting index equal to n, because if we don't find any index, our final answer should be n minus n, which will be 0, so no pairs. So initially index is set to n, and let's just start with the binary search. L less than equal to R, mid equal to L plus R minus L by 2. Now once we get the mid, let's just check if spell into portions of mid, if this value is less than success. So that means this value is less than success. So the only way to increase the left hand side is by moving the mid forward, because spell remains constant. So we have to move the mid forward. So we can say L equal to mid plus 1. Else in the sense spells into portions of M is less than equal to success. So that means we have found an index. We'll update index equal to mid, and also we'll try to move to the left to find a better index. So R will be mid minus 1, and at the end just return n minus index. If I try to submit, okay, so here we can see that if you see the constraints again, spells of I and portions of I both can be up to 10 power 5. So if we check this line, the value of spell can go up to 10 power 5, and the value of portions can also go up to 10 power 5. So when you multiply both of them, they will be up to 10 power 10. So that is out of the integer range. Here we have success as long, but spell and portions both are int. So when we do the multiplication is done in integer and the value overflows. So to prevent that, we can typecast the spell to long and then do the multiplication so that it won't overflow. Now if I submit, yeah, now it works. Finally, let's do the time and space complexity analysis. Coming to the time complexity, first we are sorting the array, so that will take n log n time, and after that we are iterating on the portions is m log m. The portions length is m, I think. Yeah, portions length is m plus. After that, we are iterating on the spells array. So we have complexity n, and in this array we are getting the find pairs function, and this function is log, and it is log on this portions array. So n log m. So we can say the total time complexity is n plus m log m. I've just combined both of the terms. And for the space complexity, this is the answer array which we have to create, but apart from this we have not created any additional space, so space is constant. And I also have the code in Python. If anyone wants to view it, I'll add it in the description as well. And let's catch up in the next video.